Hi guys. So today we're going to look at another method for solving quadratics called completing the square. So completing the square is another method that you guys saw back in Algebra 1, but this is one that tends to be forgotten the most. Completing the square is actually really useful, specifically when we are trying to take a quadratic that's in standard form and write it in vertex form. We'll also use it to solve, but we're going to start with that application first, just because it's kind of unique to completing the square. So what I mean, remember, standard form and vertex form. The example A that's given there, that's already in standard form. Vertex form is what we have down here. So we want to get something in that form so that it's easy to recognize both the vertex and the transformations. So in order to write this equation in vertex form by completing the square, I'm going to try and get this equation to look like a perfect square trinomial. And if you remember from last class when we did factoring, perfect square trinomials are in the form of a squared plus or minus 2ab, and then plus b squared. So in order to get something in that form, what we're going to do is we're going to rearrange this equation. So I'm going to take x squared minus 8x, and then I'm going to leave a blank. And then I'm going to put my plus 4. What I need to do is I need to find a number that's going to go in that blank that is going to create a perfect square trinomial. Well, because that middle term is 2ab, the way that we're going to get that, we basically need to get the b squared out of that. So what we do to find the value that goes in the blank is we're going to use b divided by 2 and then squared. So the b value here is negative 8. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. The problem, though, is I need to make sure I don't actually change my equation. And right now, if I just add a 16, I have an entirely different equation. So if I add 16, I also need to subtract 16. And that's why our directions say to have a plus blank and a minus blank, because we are trying to keep this equation balanced. Well, now what we've created there is a perfect square trinomial. So those three terms are going to factor into a perfect square trinomial. So that would be x minus 4 squared. Then we look at the two numbers that we have left. Well, plus 4 minus 16, that can just be rewritten as minus 12. So now my equation is in vertex form. So it's easy to see what our vertex is. Our vertex in this case would be 4, negative 12. All right, so now let's look at this next one. Same idea. We're going to go ahead and do x squared plus 6x plus blank so that we can create that perfect square trinomial. Then it's going to be minus 2, and because we want this equation to stay balanced, we're going to do minus blank. So the number that's going to go in the blank in this case, it's b divided by 2 squared. So 6 divided by 2 is 3. 3 squared is 9. If I add 9 to the equation, I also need to subtract 9 so that this equation stays balanced. So this is now x plus 3 squared minus 11. And now my equation is in vertex form. Vertex is negative 3, negative 11. All right, so let's look at another example. So now we're going to look at what happens when our a value is not 1. So the two previous examples were a little bit easier because there wasn't that a value. Well, if we have this a value in front, what we need to do is we need to take that value, we need to factor it out. Now, I don't need to worry about factoring into that last term. That's not really going to affect my answer because it's just going to be the y-coordinate of the vertex. So what I'm going to do is I'm going to take out that 2 from just the first two terms. So this is going to be x squared minus 12x, and I'm still going to leave my blank. Then I have the minus 15 outside of the parentheses there. So now we'll figure out the number that goes in the blank. Well, it's the b term divided by 2 squared. So negative 12 divided by 2 is negative 6. Negative 6 squared is 36. The problem here, though, when I do my subtract blank, I can't just put 36 here because 36 is actually not what's being added to this equation. We're adding 2 times 36. So since we're doing 2 times 36, what I subtract from this equation needs to be 2 times 36. So this now factors. I have a perfect square trinomial. That's x minus 6 squared. And this is now going to be minus 87. Kind of a large number, but It's still going to be our vertex. Our vertex would be 6, negative 87, and this graph would have a vertical stretch. All right, so now what we're going to do is look at another one. Same thing, it's going to have that vertical stretch on it that we need to factor out. So I'm going to factor out that 2. That leaves me with minus 5x. I'm going to leave my blank. 7 is on the outside here. If I'm adding something, I also need to subtract something again to keep this balanced. To figure out what goes in the blank, I take the b value, I divide it by 2, and I square it. So this is negative 5 over 2 squared. So that gives me 25 over 4. And remember, what's going to go in that blank, it's not going to be, the other blank is not going to be 25 over 4. It's going to be 2 times 25 over 4. Well, 2 times 5 over 4 would be 50 over 4. And that's a highlighter, sorry. Which can reduce to 25 over 2. Well, now I can factor that. That's my perfect square. So it's x minus 5 over 2 squared. And then that's 7. You get a common denominator. That's 14 over 2. So 14 minus 25 would be negative 11 over 2. I should have wrote minus there. So my vertex of this equation would be 5 over 2, comma, negative 11 over 2. All right, so now we're going to switch gears a little bit and we're going to look at solving by completing the square. So to solve by completing the square is a very similar process, except our goal is different. Our goal is not to write this in vertex form. Our goal is to get x by itself. So what we're going to do this time, instead of just taking that c value and kind of moving it to the side, I'm actually going to take that c value and move it to the other side of the equation. The reason I'm going to do that is just because my goal here is to solve, so I do eventually want that square root to be by itself. So I'm going to go ahead and add 5 to both sides. And now I'm going to do completing the square the same way I did. I still need to add my plus blank, but what's a little bit different this time is I added something to the right side of the equation. In order to keep it balanced, I'm not going to subtract, I'm actually going to add to the other side of the equation. So whatever I add, and let me go ahead and reorder that so it's a little easier for you guys to see. Okay, so whatever number goes in the blank, I'm still finding it the same way. I'm still taking the b value, I'm still dividing it by 2, and I'm still squaring it. So I'm going to get 4. But if I add 4 to the right side of the equation, if it stays on the same side of the equation, I would still subtract it. But since I've already moved it to the other side, I'm going to add it because, again, it's keeping this equation the same. So now I have 9. Then this is going to be a perfect square, x minus 2 squared. And then at this point, we're just solving by square roots exactly like we did last class. So go ahead and square root, which remember will be plus or minus the square root of 9, which is plus or minus 3. So now to get x by itself, I'm going to go ahead and add 2. So this would be 2 plus 3 and 2 minus 3. So I get x equals 5 and x equals negative 1. Now, what's a little bit nicer when we're solving by completing the square as opposed to writing it in vertex form. Instead of just factoring out that 2 and rewriting this equation, you can still do that, but what's actually a little bit easier if we're solving is actually instead to just divide the equation by whatever that a value is. What's different between those two is that when we're solving, we're not changing the equation when we divide by something. Whereas that last one, when we were writing the equation in vertex form, we had to know what that a value was because it affected our equation. It was our vertical shift. But when we're solving, we're just finding the y-intercepts. It doesn't matter how far we stretch away from those x-intercepts. It just matters what those x-intercepts are. So we're not changing the equation when we divide everything in this equation by that value. So we're going to go ahead and divide everything here by 2. So 0 divided by 2 is 0. This becomes x squared minus 2x minus 4. And now I'm going to do the same completing the square process that I've done in all my other examples. So I'm going to move the 4 over because I'm solving, and I'm going to leave a blank. I'm going to leave a blank over here. The number that goes in the blank, Negative 2 divided by 1, or negative 2 divided by 2 is 1. 1 squared is 1. So that leaves me with 5. This is going to factor into x minus 1 squared. I can square root both sides. So I'm going to get plus or minus the square root of 5 is equal to x minus 1. So my solutions would be 1 plus or minus the square root of 5. All right, so the last one that we're going to look at, very similar. Again, we need to, this one's actually already set up really nicely for us for completing the square because that c value is already moved. But again, we want that a value to be 1, so I either need to factor it out, or since this is solving and it's in a full equation, I'm going to go ahead and divide it. So this would become 7 over 3 plus blank equals x squared minus 3x. So to figure out what goes in my blank, I'm going to take the b value, which is that negative 3, divide it by 2, so that's negative 3 over 2, and square it. So that becomes 9 over 4. And I'm going to put 9 over 4 in both blanks. This is going to factor into x minus 3 over 2 squared. And then over here, to add these together, I need a common denominator. So multiply by 4, and then multiply by 3. And now that I have that common denominator, I can combine those together. So that gives me 55 over 12. So I can go ahead and square root this. Now when you square root a fraction, you are square rooting the top number and you are square rooting the bottom number. So now, in order to actually write this final solution, what I need to do is rationalize my denominator. Now you can rationalize, I'm going to go ahead and simplify this before. So the square root of 12, remember, can simplify. It's divisible by the perfect square of 4. So that's going to simplify to 2 root 3. So let's go ahead and simplify that first. And then to rationalize that, in order to get the square root out of the bottom, I need to multiply both the top and the bottom by the square root of 3. And what that's going to give me now at the top of the fraction would be the square root of 55 times 3. Which is the square root of 165. And then at the bottom, that would become just 6. And then my last step there to get x by itself would be to add 3 over 2 to both sides. So I would get x equals 3 over 2 plus or minus the square root of 165 over 6. All right, so that is it for completing the square. Again, it's really important that we use this in order to help us get our function into vertex form, but it's also a nice way that we can also solve quadratic equations.